Ah, another physics video on the Inmendum channel. Yeah, sorry. But they're worth going over. Some of this science that's really crazy. So this is going to be on this black hole crap, but the black hole crap really is about velocity and what really causes time dilation, and might end up on the subject of lensing a little too. But anyway, two funny comments, right? On one of the last physics style videos, the guy writes, "These space-related videos of yours are a breath of fresh air and a nice departure from the anti-natalism thing. Absolutely essential viewing. Hope you cover more space moving forward." And then, on the other one, this asshole writes, to Jejeskirganarkanile, whatever the fuck that name is. Anyway, I mean, these, such assholes. I mean, anyway. "You lost me when you started to criticize relativity theories." Oh, okay, that's verboten. Oh, holy grail of science, huh? Apparently, it's the Jeebus story, and nobody could ever find anything defective or broken in those theories, right? Never, ever, ever. It's so ultimately proven fact. Sorry, fuck you. Please stick to antinatalism and ethicalism where you are good at it. Whatever. I'm good at a lot of things, jackass. And what I'm really good at is detecting jackasses. And you're a jackass. I can detect how small your penis is from here. That's how good I am at this. Clearly physics isn't your subject. Well, clearly I don't think it's your subject, because you can't make what's called a rational counter-argument in any kind of form that has anything to do with the subject. You see? So you can't tell somebody they're wrong and then say nothing except "I say so." You don't know how lame that is? You can come up with one kind of counter-argument. God doesn't exist because I say so. You can't just say something like, because evolution is a perfectly good explanation of our existence, we don't need a fable or a fairy tale that has no evidence to support it as an explanation. You couldn't do just that, something like that. What physical fact, what experiment proves me wrong? Asshole? Oh, nothing. You are making yourself to look right clown here. Well, you don't speak too good at English, but whatever. Fuck you. Can I say that louder? Fuck you. This is not an argument. What is that? I don't like you. So go make some videos so I can just post in the comments section, "I think you probably smell like dog shit." Huh? I'll just speculate. "You seem really stupid. You're making a fool of yourself." Gee, that's so hard to do, right? I could type that on any video on the internet. And what is the person supposed to do to defend themselves? Redo the video just for you and explain how that wasn't foolish and that part wasn't foolish, and you certainly didn't counter-argue any of these parts, you dumbass. So how exactly have you demonstrated this foolishness you're talking about? Huh? Fuckhead? Oh, that's right, you haven't. So anyway, goodbye. Fuck you. Ugh. Anyway. Alright, so here's the black hole bullshit. And so, we'll just, as soon as he says something, I'll just say, and no, it doesn't work that way.
Seen and heard a lot about black holes. Well, today, I'm going to try to make you rethink all of it, down to what the term black hole even means.
Right, and what's the point of that? Because he's going to do it in this way where he's not going to really demonstrate with like some kind of evidence. He's just going to say, "Oh yeah, if you think this is this, well, it's not because I say it's this." And, it's not really very useful. But anyway, it's, to my purposes, quite useful because it just illustrates how full of shit this science really is. They're just making it up. Right, space-time. Well, there's no such thing as space-time. What there is condensation of matter. Okay? That's energy. Energy gets condensated. See, the ether is actual little bits flying around, right? So just imagine every little pixel here, and it's all moving the speed of light, and it can never do anything else. So for all the people who love Tesla, It's just like Tesla's ether idea, except the ether is made of energetic parts. That's where the energy all comes from. Energy doesn't come from something. It is everything. It is already energy. And we just recognize the parts where there's an imbalance. So anytime there's an imbalance in energy, then we say, hey, that's got energy. But it's all got energy. You only see it when it's not even. Pressure-wise. It's like us. We only notice changes in pressure, right? The pressure's always around us. We don't notice it at all. But the wind blows, changing the pressure a little bit, and we notice.
Today's episode will only talk about black holes from the perspective of classical general relativity.
Yeah, well, that's right there. He just lies, but then you start talking about Newton, and then you start talking about this, and so that's just a crock of shit. That's not what he's going to do in this video.
That means no Hawking radiation, no string theory, and no quantum anything.
Yeah, well, he brings up Hawking radiation, so blah blah blah. You know, what's the point of saying no Hawking radiation when you're going to say the words Hawking radiation later in this video?
Baby steps. Trust me, if I do this right, it'll be mind-blowing enough.
No, it really won't. It'll just be kind of irritating and annoying.
Now, it's a lot harder to say what I want to say about black holes if I make this video self-contained.
Alright, well, yes, geez, if I actually rely on showing you a piece of evidence for what I'm going to say, except instead of, you know, cartoon pictures that we made up, you know, like I'll show you gravitational lensing, an actual image of some kind of actual celestial gravitational lensing instead of some sort of made-up picture that has nothing to do with any reality whatsoever. Why don't you do that for a change? Why don't you actually show us why you think something is the way it is? What evidence proves it?
Treat gravity Einsteinianly rather than Newtonianly from the outset. It will help a lot if I can rely on technical terms like geodesic or flat space-time.
Or complete fucking twatty blue bullshit. I mean, what the fuck? I mean, you're just making up shit, and you're going to make up this way of converting matter into some sort of superstructure that doesn't even connect whatsoever. Not doesn't connect to Newton, and certainly doesn't in a way connect to Einstein. I don't think Einstein said God doesn't play swishy, make it all disappear into one peanut with the universe either. I mean, you know, this whole idea that you can somehow make super condensed matter that's so condensed all the matter in the earth gets condensed into a pea. That's the kind of shit they're talking like. Like a black hole is made up of energy so condensed, matter, that something the size of the mass of the earth gets condensed to a pea. So somehow it's not made out of lead or uranium. It's made out of something so fucking dense that, you know, it's a zillion times denser than uranium. So it's making elements that don't even exist. I don't think Einstein would say that's happening.
And if I can draw a space-time diagram or two. We all need to be on the same page with this vocabulary, so if you need a refresher, go watch our relativity playlist.
Oh, no, I'm not going to do that. Yet. Right now. Some other time, maybe.
And finally, to minimize miscommunication, I need a favor from you. I need you to put your preconceptions about black holes aside, and for the next few minutes, become tabula rasa, and let me tell you a story about me, a pony, and a very acrobatic monkey.
I don't know what a tabula rasa is, but I'm not becoming one. No way. I cut my nuts off.
Suppose that I'm very far from a black hole, and there's a pony orbiting the black hole. She's close, but not that close to the hole. Don't worry.
Well, if she's orbiting, it has to be a specific distance, but okay, go ahead. Let's play.
Fact. Events that happen at a normal rate, as far as the pony is concerned, will happen in slow motion according to me.
Right, so he's saying that when I look at the pony's going to be doing something different than the pony's actually doing from the pony's perspective. No. What's really happening, okay, is that all velocity is absolute. And when you acquire velocity, what it means basically is that atoms are things moving. So the energy's already in the atoms. So again, if I went back to this, all these little pixels, and just said every little pixel that makes up this image is already in motion, and it's moving the speed of light. And just pretend they're all moving in little tiny circles, just to make it easier to understand. And that's why you don't see them going anywhere, is because they're caught in a pattern, okay? So what happens with matter is that the energy is caught in patterns. It's still energy. If you let it loose, it'll fly like a nuclear bomb, right? You have a nuclear bomb, basically what you're doing is breaking a few nucleuses, you know, damaging them a little bit, so they become a little bit smaller, and then all the excess bits that they can't hold anymore fly off. And then they cause other atoms to do the same thing, and that's a chain reaction. And what's happening is the energy that was trapped in the matter, E equals mc squared, is released. It's set free to go in straight lines again instead of being caught in patterns. Well, anyway, so the idea would be is that when you have velocity, so I'm back to my dancing argument. So if you imagine this guy dancing, he's just going dance, dance, up and down. And then I say, please move to your left. So he's jumping up and down as fast as he can. And I ask him to move to the left as he's jumping up and down. The effect is going to be he won't be able to jump up and down as fast because he's going to have to, pieces of him are going to waste time moving in a direction. So he's going to be covering more pixels of space, so to speak. And that's time. And so he's going to slow down how fast he can jump up and down because he's going to have to spend some time going this way. It's a really, I mean, it's a perfectly, can't you understand that as a metaphor? And that the faster I ask him to move in a direction, the slower the up and down is going to be, because it's going to get stretched. You get it? It's going to have to take more time because it's going to go from this 1 second to now it's going to take a minute, and then it's going to take an hour, because he's going to have to go, the more distance I make, the line gets more and more stretched out until it gets straight. And that's what happens when you convert matter into energy, is you take the stuff that's going around in circles and you make it all go in one direction, and so the matter no longer exists, right? It's the school of fish, and then all of a sudden I say, you're all free to go, and then all the fish go off in their own direction. Or if they happen to all be pointing in the same direction, then they all just go in the same direction. So they could still look like a school of fish, but they're not really matter anymore, because they're not swirling. They're all just going in one direction, so they're more like a laser beam or something. But anyway, don't want to confuse you. So his argument is that he sees this different than this sees anything. But the point is this is seeing different. It's not that you're seeing differently, it's that you're seeing differently. If your matter slows down, if the machinery slows down, the orbits of each electron within the atom, everything is slowed down because it's now taking a little bit of time to move. So the faster I move, the slower the metabolism of my matter. And it's that slowed metabolism that makes me function slower. So what's really happening is the faster I go, the slower my clock would get, the slower the pendulum would swing. So there is no relativity. There's just the fact that if I'm going fast, everything slows down here, but nothing slows down over there. So if I'm looking at something over there, and let's say my eye still could work properly, over there hasn't changed any. I'm changing. The thing moving is changing.
Day for her might be months for me. This is called...
It's like when they do that, they do that light clock thing, and they say, okay, we're going to have a photon, and it shoots over, hits a mirror, and bounces back. See, that wouldn't work in their little elevator experiments, because the time it would take the photon to go at the speed they're moving, the mirror moved out of the way. You can't build such a clock because the mirror disappears.
Gravitational time dilation, and the same thing happens around Earth, just to a lesser degree. Atomic clocks in high-altitude orbits will get ahead of clocks on the ground by a few microseconds each day, which is...
Well, see, they should get behind by a few microseconds each day if you were arguing that the plane is going faster. So what you're really saying is the thing out here is going slower. Okay, so that's the joke of this thing. The thing out there is going slower than we are here on the surface. And the difference is because we're in the heavier gravity. So I've made this argument before, but you can sort of imagine a circle. So here's a circle. And if I went really zoomed in on it, you might see that it's least. That means that, you know, like text has all those little jagged edges when you microscopically move in on it. Well, when you microscopically move in on a circle, it's got a ton of that leasing happening. And the truth is the further out you are, the bigger the leasing, which means it's less distance. And the closer you are to the surface, the tighter you're leasing. So you're going up and down many more times in a period of time. So time is the same, and what happens to something on Earth is it's going up and down a lot of times. So it's moving a much faster velocity because it's doing much more, covering much more distance. Where the thing out here is getting leased into the gravity. It's changing from this square trajectory. You know, its velocity is this way. It ends up getting acceleration down by gravity. And the result is this, it's really just bouncing through that circular path. And again, the bouncing on Earth is much tighter than the bouncing out here. So technically this thing's moving slower because it's bouncing less. So that's another metaphor you should be able to understand, that if I go straight across on this circumference, nice and smooth, that line isn't very long. But if I'm jumping up and down as I go on this line, you can understand I'm traveling much more distance. And if I do those two things in the same amount of time, this guy, the one doing the smooth thing, has to be going much slower than the guy bouncing because he's traveling much more distance. Distance is part of what decides velocity. And matter is already made of energy moving as fast as it can. And so if you move the matter, give it a velocity, the only way you can make it move some other way is that the fastest it can it was doing, it has to be doing slower. Just makes sense.
Tiny, but GPS doesn't function properly if you don't take this into account. Okay.
Right, so just understand that he basically just said it backwards in the sense that he's basically implying that satellites are going faster, when in fact the clocks have to be compensated because the clocks are, in fact, going faster. They have to be slowed down. So it's exactly the opposite of what he implied.
Now suppose that I send a tumbling monkey falling radially toward the black hole. As he tumbles on, I see his rotation rate become more slow motion.
So this is sort of a good metaphor for me, right? Because, see, what's really happening is the presumption is that this thing is accelerating towards the black hole. Nothing just goes at a constant speed towards a gravitational body. It always gains more acceleration as it gets closer by this inverse square rule. The gravity essentially quadruples with every half. So when I go, when I cut this, when he's here, he's going to be going 4 times as fast per second. He'll be gaining 4 times the speed per second. You know, by the time he gets here, he's going to be going much faster as he gets here, because it's every second the speed is increased. By every quanta of time, there's an increase in velocity imposed by the acceleration. The acceleration is constant, the velocity increases. But the acceleration also increases as a percentage of your as a component of your velocity based on how far away you are from the object. So anyway, so he's talking about how fast this thing is going to tumble. He's saying, well, this monkey starts tumbling slower, and that's sort of the implication that, well, if it starts going faster, it can't tumble as fast. You get it? So he's sort of making my argument for me.
But I also see him pick up translational speed.
Well, and see what he means by that. He's picking up speed, heading for the because of the velocity and the acceleration imposed by what we're assuming is the gravity of the black hole. I mean, this is so stupid. You know, I mean, he should be saying the monkey's not just floating in space; he's being affected by the gravity of the black hole. Shit. I mean, velocity and acceleration are important parts of this. And I mean, you should at least have arrows indicating the size of his velocity, like make the arrow getting bigger and bigger because its velocity is increasing or something to indicate the fact that the monkey's moving faster and faster.
Just as I would if he were falling toward Earth.
Right, well, he's not just falling towards Earth, he's accelerating towards the black hole. So you should say accelerating towards Earth. There's no atmosphere here to slow him down, there's no terminal speed, none of that bullshit. This thing is just going faster and faster and faster and faster. With every single tumble, he's getting closer and closer. His acceleration is increasing and his net velocity is increasing with each tumble.
That is, until he gets really close to the black hole. See, eventually, the monkey will cross the black hole's edge.
Okay, well, you know, crossing an edge. Now that's, you know, this is just a thing said, right? Now the strongest point of the Earth's gravity is at the surface of the Earth, because you have this huge density difference between, say, you know, the atmosphere is only 3 miles thick, you know, so you've got a very thin atmosphere here of any real thick, you know, of any real atmosphere. So the real atmosphere is very thin. And so there's a real dividing line between the material Earth, made up of hard elements, and space, which is made out of very loose atoms, a few, you know, just little bits. So there's a huge density difference. So if you're sitting here on the surface, there's very little mass on this side of you and a lot of mass on this side of you, the whole diameter of the Earth. And so this is the strongest gravity. And as you go further in, ironically, the gravity gets weaker because now there's some mass on this side of you and less mass on this side of you. Now you've reduced this diameter on this side and you're increasing the diameter in this side, and it's really the imbalance in that condition that decides your gravitational acceleration. So now his acceleration, he has a velocity, but now what's being added, his acceleration would start slowing down. His velocity wouldn't slow down, but his acceleration, the amount he's going faster with each turn, starts to decrease.
Without him noticing anything unusual. But that's not what I see. I see him weirdly slow down his progress until he's floating.
Right, now, so this is all just plain theoretical bullshit, right? This is all just some number that says, some equation that says this is a truth. But this isn't a truth. By the time he gets to this surface of this black hole, he is moving, theoretically, as he crosses this event horizon that these people made up, this idea of the black hole where the escape velocity now exceeds any velocity attainable. That is, to escape, you would have to go faster than the speed of light, right? Well, as soon as he traverses that, the monkey no longer exists. The monkey is now just something moving in a direction. There's no more dancing. Nothing is dancing inside anymore. None of the atoms have orbitals. No electron has orbitals. No element of the nucleus has an orbiting bit. They're all not going in any circles anymore, and all the bits are going directly into the black hole. It's a complete conversion into energy. Now the question is, when this energy goes into the black hole, what happens? And that's I think they've also got that one way wrong. The black hole, it can't be made out of nothing. There's not some space. You go flying through the black hole and you just warp into this little warpy place in there. No, 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 no. You're already now light. You're already just photons. Now the question is, what happens to those? How do those get condensed into the black hole? How do I shoot a bunch of photons at lead? Okay, they are the element, the heavy elements, the really compressed energy inside that black hole. How do I shoot energy into it and have it absorb it without there being any impact?
Right outside the black hole's edge. At a certain point, I see him in suspended animation. Not rotating, not progressing, just frozen.
Right, so based on what logic, right? You could understand the thing is now moving as fast, incredibly fast. It's caught in the strongest, incredible strong gravity, stronger than the surface of the sun, incredible strong gravity. And it's accelerating with very fast. And when it crosses that event horizon, it's basically accelerating now where, again, it has to be going the speed of light, which means it can no longer be matter. Matter can't go the speed of light, so there's no monkey anymore. The monkey is not a thing anymore. The monkey has been degraded by the velocity. The velocity has stripped the matter of its identity. It can't be dancing anymore. There is no more dancing because now the energy, the bits, are moving as fast as they can that way. There's no up and down, there's no anything. There's just going that way, period. And that's energy. So there is no, it doesn't stay anywhere. It's just such crap.
And the pony agrees with me. So does
the pony and the this and the
another pony that's using powerful rockets to hover much closer to the black hole's edge. In fact, so would any observer, inertial or otherwise, who is always outside the black hole's edge.
Right, so his argument is anything outside this edge is going to pretend the monkey is frozen there. It didn't go anywhere. It stopped moving. And again, all that happened is the monkey converted into energy. The monkey ceased to exist. That's what really happened. And even if you said, even if there was some way that it wasn't going that fast, the idea is the monkey is, in a sense, becoming cryogenic. Okay, it's cryogenic. So as the monkey's moving faster, you can sort of think of it as being, that extra velocity. You can sort of think of it as being frozen. The monkey is being frozen. Okay, the matter, in the sense that its metabolism is degrading so significantly. And there's a point, though, when the metabolism would degrade enough where the atoms would just fall apart. They can't just infinitely slow down. You can't, like if you envision an electron circling, if you just even, well, any bit you envision of the classic description of an atom as having these jiggling parts, these moving bits, you can sort of understand that you can't just slow them. It's like slowing the Earth down in its movement around the sun. You could sort of understand that if you slow it down enough, it's just going to fall into the sun. You can't deny it. There's a point where you break the function of the atoms if you attempt to move them any faster. Now, again, that's my argument, that there's no such thing as moving 3/4 the speed of light for material objects. Because if they have any kind of complex structure, like a protein or some sort of complex compound, all the bonds and all the connections that are holding that matter together are going to dissolve because it's no longer obeying the rules of to keep spinning. You have to keep spinning. If you stop spinning, you fall over. That kind of thing. The rules are broken. All right. Well, anyway, I'll get back to this. Yeah. I'll be back after dinner or such. Something like that. Alright, I'll do a little of this before dinner still. Yeah, let dinner cool down a little. 10 minutes. So there was something I wanted to point out. Look, Einstein's relativity, all his theories are, this whole bent time thing is all based on this idea of a convergence, okay? His notion that, okay, space is converging where there's mass. And my argument is that it's not space that's converging. It's this ether, okay? The fact that the whole field is made out of these little BBs, and they're all moving in, as a whole universe, they were moving, in every direction equally. So any one point in this space would feel the same pressure from all sides. And so, just like we don't feel the pressure, if the pressure is coming equally from both sides, I don't move. Nothing pushes me, so to speak. But if there's an unevenness in the pressure, then I'll tend to acquire an acceleration, a drag. I'll be dragged with it. it's a little more complicated than that because every little bit is what's moving. So here's the part, like the fundamental issue is that I'm arguing, you know, that gravity is a thing. It's a physical thing. It's made of something, and it's just this shadow idea, and it perfectly fits with the inverse square rule of, you know, twice the distance, 1/4, or 4 times the gravity. If you move, if I go from this far away to half that far away, the force of the hand is now 4 times bigger. That kind of thing. I've already been over this, but it's important. And the idea is that gravity is not a force that's affecting big things. It's affecting the little things the big things are made out of. It's affecting the nuclear bits, the little tiniest bits are being affected by gravity. They're being influenced because the BBs are hitting those little bits. And for the monkey to move, every single little bit inside of the monkey has to acquire that directionality for some portion of time. For some bit of time, it has to move in that direction. So you can think of it almost digitally, like it has to spend a little bit of time going this way, and then some time going this way, and then this way, and then this way. You can almost think of it like a little pattern of digital movements, and that some percentage of them, for it to move in a direction, has to be in that direction. And if I go to an absolute velocity of the speed of light, that you would understand that there's now no more room for any other direction. There's only one direction. And you're now back to being quanta. You're back to being in the field as energy, except now you're almost like a laser beam or something. You're just a group of it moving in one direction. And the other thing to understand is that if as matter condenses, it means that space expands just automatically. The more matter you make in the universe, the less bits, the less BBs that are free out in the rest of the universe, so that pressure gets weaker. So in a sense you have to understand that gravity is like, its strongest would be across this whole diameter, would be the strongest gravity, because that's the most of the BBs being blocked. So the idea is gravity is like there's BBs going on both directions here, and these two things are blocking this direction, and so there's less BBs coming this way and less BBs going that way on these two objects, and that's why they're pulled towards each other. And it perfectly works out, like I said, with Newtonian inverse square. I mean, Einstein didn't disagree with inverse square. That's established fact. And yeah, it's perfectly consistent with that. So anyway, I just wanted to throw that in as a context, but that's the thing where you have to understand that this guy doesn't understand that. And so he's talking about it like space is doing something. And he's not understanding that, no, the force is there, and these objects, depending on how they're structured, will block force. And it's the imbalance created by that blocking that you see, that is noticeable, and that it has an effect. Nothing happens if the force is balanced. It's when the force is imbalanced that something happens. Oh, I should get into radiation stuff. Well, I'll wait till later.
Even if the ponies and I were immortal, all of us would agree that the monkey's life just doesn't progress past this frozen moment.
Right, so do you really believe that? Do you really believe that something would crash into the Earth, for example, and let's say I could quadruple its speed? So I shot it into the Earth. It wasn't just the Earth's gravity, but I gave it super duper velocity. That somehow, when it got to the very edge of the ground, when it was just ready to hit the ground and go splat, it just froze. Just said, I'm frozen. No, you know that. You know that's bullshit.
The monkey knows he crosses the edge. I mean, he was there.
Well, see, this is, again, based on what? Like I said, for the monkey to be there, the gravity, okay, by this man's argument, right? He's saying this is like 1,000,000 stars worth of mass in this tiny bit of space. The gravity at this edge is it's like we go like 10 feet, 10 meters per second. It's like 5 million miles per second per second. It's that kind of intense speed, all right, acceleration at this point. So this idea that it's slowly just drifting, no. It's gaining acceleration. It's going incredibly fast by the time it gets to that point. And even if I just stood it there, even if I just placed the monkey there, so he never even had any acceleration or velocity, and I just placed him right there on that edge, the intensity of that acceleration is so intense that he's going the speed of light like that fast. He's going from 0 to 365,000 miles a second that fast.
But everyone else insisted he never does, even after an infinite amount of time on any of our clocks. Do you get the...
See, on any of our clocks, I mean, it's just such a pile of crap. You know, any of our clocks. Well, number one, he doesn't have a clock anymore. The clock is gone. It's broken. There's no matter to make a clock out of. The pendulums don't swing. Nothing happens. There's no clock. This clock is gone. All right, and this fucktard here has to be going incredibly fast to stay in the orbit of this black hole. So its clock is, yeah, it's moving really, really slow. I don't know about the jet propulsion bitch is doing the same. It's even in more trouble, acceleration-wise, one would imagine. Again, it's that argument. The closer you are to the gravity, the higher, the more vibrating you're going to be doing. So the further out you go, even if you're going faster by appearances, you're not really going faster because your actual speed is your atomic speed. Again, gravity is affecting the tiniest bits of you. I could just expand you to twice as big and just put newspaper between all the little bits. You know what I mean? Just blow you up to twice the size and just stick little pieces of paper between all the atoms, just to give you the idea that they're separate atoms. And you'll do exactly the same thing as you do as a solid human. Gravity is not affecting your mass. It's affecting the little tiny bits. You're a collection of gravitationally relevant elements. You're not gravitationally relevant. Only your atoms are. Only the BBs inside of your matter are being affected by gravity.
Freaky this is? The monkey is saying that certain events happen.
No, the monkey isn't saying the event happened. So again, they call this the event horizon. There's no event. The event, the event is smash. Now this energy that was the monkey, the matter that was the monkey, has been converted into energy, and somehow the energy has been reconverted into some sort of matter that's this black hole is made out of. Some sort of supersonic special matter that somehow is mega more dense than uranium even, right? I mean, I wish somebody would give me the number, right? This guy's later going to say that the you know, to turn the Earth into you know, to have an escape velocity the same as a black hole, where it's the speed of light kind of thing. You'd have to go the speed of light, and you still couldn't get off the surface. You would have to convert the Earth to 3 centimeters. Now, one could argue, how could you possibly condense mass into 3 centimeters? The entire mass of the Earth into 3 centimeters. What would this matter be made out of? Lead? How big? So I would like to know if somebody can figure it out. If the Earth was made out of solid lead, or uranium, pick one. But I mean, just use lead because it's stable. How big would the Earth be? So if you got rid of all the water and all the compounds and all the other chemistry and all the other bullshit that the Earth's made out of, and just made it out of solid lead, what would its radius be? And then I'm going to compare that to this idea that he's saying black holes are made out of matter, out of stuff, energy, collected energy, that somehow is retaining the gravitational blocking force, the substance, the mass, and yet isn't taking up any of the space. And I'm going to argue, no. Sorry, that doesn't happen.
Everyone else outside the black hole says that those events never happen, ever. In other words, there are apparently events that, according to us out here, cannot consistently be assigned a when.
Right. Now, this, again, events it has a where, but it doesn't have a when. Now, isn't that... I mean, these kind of... I mean, you could call it, oh, it's a paradox. No, it's nonsense. This is reason to think maybe you have got it wrong. Maybe you don't have the right understanding of the mechanics if all of a sudden now you've abolished when. I mean, time is a component of speed and distance, so you're saying it has no speed and it has no distance. Well, yeah, I guess I could say the same thing for rockets that go up and go straight down into the earth. Well, it's not winning anymore. It's not doing any time distance thing anymore because it's smashed. It's a pancake, and that's what this fucking monkey is.
From our frame of reference, outside the black hole, those events just don't occur, even if we wait an infinite amount of time. Okay, you got...
Well, again, so events is where this all breaks down, because these people don't understand that velocity, again, it's that dancing thing. That events are you dancing, and that if you have so much velocity that you're moving the speed of light, you're not eventing anymore. You're just moving the speed of light. You're light. You're converted into energy.
And all that, here's the thing. A black hole is that set of events. According to observers like the monkey who are at those events take place at spatial locations inside that black blob we see.
Right. So now he's saying that there's things inside the black hole doing something. So here we have this super dense material, 1,000,000 times more dense, more massive than lead, more massive than uranium. You know, elements so compacted that they're doing something so uncomfortable for photons and neutrons, protons to be doing, that they're actually leaking radiation. You know, they're degrading because they're in a condition that is not comfortable for energy. And yet he's saying events are happening. Yeah. What?
In the sky. But the blob, the black hole, is not just a set of locations. It's all the events that have ever or will ever take place there, according to observers who are physically there.
Right. Now, does that make any sense to you? I mean, you could argue that any matter has a history. And, you know, when it goes someplace where it stays for a while, well, then you could say, well, its collective history is now locked up in that place it's staying for a while. But does that make any sense to you as a way of perceiving something? I mean, there's no event. The black hole is not a frickin' kitchen, you know, and you're baking cupcakes and cookies and you're watching TV and none of that stuff's happening in there. There's no events happening in the black hole. This is, you know, sorry, I mean, this is frickin' silly. Anyway, I'll be back. Back. Yeah. Anyway, it's later. Much later. Anyway, I was just looking at this, you know, all events that take place at these locations. So this whole idea that a black hole would have just one location, you know, that stuff could happen inside of it as locations. Again, just think about, so what, the black hole never moves? So then we've gotten rid of some measure of relativity in the sense that there is no relative position. There's an absolute position now for black holes. But anyway, there's no room in there for all these activities. No room. Anyway.
The black hole is not a region of concurrent happenings with the outside world that the pony and I are just unable to see. It's not a visibility issue.
Okay, says he. So he says it's not a visibility issue, and it really is, frankly. It's not even it's a visibility issue. The fact is that when stuff moves slower, when the metabolism breaks down, the function changes, and it's not doing normal things anymore. So it can't be viewed as normal because it's not normal.
Instead, the black hole is the collection of happenings that we say don't happen at all. And that black blob you see in the sky...
Right, so this is scientific. It's a collection of happenings that don't happen at all. That we say don't happen at all. Ooh. Yeah, it only happens over there. It didn't happen anywhere like in the real universe. This sounds like a holiday theory.
Hi.
Oh, fuck you and your damn cunt.
If there's an empty
Fucking
lot,
goddamn
someone...
bastard fucker. Anyway. Yes, I know about ad block. Yes, that's not the point. This is how we're getting the internet. And it has to do with the provider of this video. And like I said, they don't give you the choice to skip. They're just being obnoxiously obnoxious. For more money. Money. So they can finance all these effects.
It's what it ends up looking like in ordinary spatial and temporal terms when you delete entire occurrences from every external observer's self-consistent record of the history of the universe. By the way...
And so every observer doesn't see the happening that is a happening. So it's still a happening, even though no observer could ever observe it. Oh, fuck.
For every particle that enters the black hole, some event on its world line is always the last event that makes it into my movie of the history of the world, out at time infinity. Okay, this final batch of events, for all objects that enter that black void taken together, is called the event horizon of the black hole. The horizon is not just a spherical surface in space. It's not a shroud. It's a surface in space-time. It represents the last events to which you can even assign a when.
Well, whatever. I mean, this is all just based on the fact that the math has no... It can't go inside the black hole. Okay, so once you pass the gravitational convergence, right? That's what Einstein is just saying. It's a nice image. You know, that there's a convergence. That's what gravity is. And so he's calling it space that's converging, but it's actually this pressure I was talking about that's converging. And the trick is that once it passes the event horizon, which you could just say the surface, of the density of the matter, where the matter is more dense on one side than it is the other side. Once it passes that, the gravity gets less. So it's completely inverted. It's no longer a convergence once you go past that line. It's now a divergence.
So if a black hole is a bunch of events, then why do...
Just simply, the gravity is strongest here, ironically, or interestingly. Okay, so you're getting pulled, and once you pass that line, well, you're not getting pulled as strongly anymore. You're getting less pulled, and then once you go past that line, you're getting pulled the opposite direction. So it's this whole idea, this is where the change takes place, and that the convergence is no longer, it functions no longer by the same mathematical principles. It's no longer in the inverse square rule, no longer applies once you cross this line. Now the exact opposite happens. Your gravity gets weaker and weaker, and once you get to the center, your gravity is 0. I mean, obviously you could already have a tremendous velocity. If you could pass through matter, your velocity would still be incredibly high, so you just pass right through the other side, and because your velocity is based on your acceleration created by gravity on this side, theoretically you just go right through and end up exactly where you were on the opposite side with the same velocity you started with.
We talk about it as if it's an object. Here's why. For simplicity of presentation, let's pretend that the sun...
Yeah, whatever. Simplicity of presentation. You mean making up realities that don't exist in reality.
...a perfect sphere. It determines the space-time...
Well, you could have just made a perfect sphere then instead of putting these stupid lumps on it, so that really didn't help any.
...and geometry in its neighborhood, the resulting geodesics of which correspond to things like radial freefall, orbits, etc. Now, if I replace the sun with a spherical black hole that's around 6 kilometers across, and I'll tell you...
Right, 6 kilometers. So he's just reduced the sun now to 6 kilometers. So somehow he's taken the mass of the sun, which is okay, it's hydrogen and helium, and now made it into, say, double uranium or triple uranium or I don't know how big the uranium molecules would have to be able to condense the mass, the matter, into 6 kilometers. But that's what he's saying. Matter, which is a condensation of energy, E equals mc squared, is somehow now condensated to some proportion that we don't see anywhere in the natural universe. We don't see any elements that dense.
Later how I got that number. The geodesics beyond where the sun's edge used to be remain unchanged. Earth will...
I mean, let's be clear. When we make them, right, when we make elements, really big elements, they fall apart almost instantaneous. They have a half-life of 2 minutes, you know, and they just degrade really, really quickly. Well, 2 seconds, and for most of them. So, I mean, if you try to make the, whatever, plutonium or something, it doesn't stay that element very long.
Breathe, of course, but its orbit won't be any different. So, as far as Earth is concerned...
Right, so he's just basically saying this is the old sun, we've cut it to 6 kilometers, so this isn't even in accurate proportions, obviously. 6 kilometers would be insy bitsy bitsy, and obviously there's, but let's not even go into that. But he's just saying that the inverse square rule will kill the gravity. So if I make this black hole small enough, I can reduce its effect gravitationally across distances to where you wouldn't notice it. So you could put a black hole in the center of the sun, just get rid of the sun altogether, just create a little BB of black holeness, and maintain the same gravity, because the inverse square rule will annihilate the effectiveness of the gravity across that distance. But again, this is, who's demonstrated that you can do that to matter or to mass? I don't think they've demonstrated that.
That black hole generates the same space-time geometry out here that the sun does.
Right, and I don't think those are the kind of black holes anybody's talking about. I mean, I just argued some black hole thing on the other channel, that was supposed to have bent a whole globule cluster, and it didn't suck part of it out like they thought it was going to, but it definitely changed it. It definitely was affected by it, because it completely changed its trajectory, and so it's obviously a very massive black dark object that it came in contact with, but it was no 6 kilometer bullshit. It was big and it had a lot of gravity. I mean, what's the point? I don't even understand what his point is here. When the point is that we're talking about galaxies being manipulated by these black holes. They do have gravity. They do suck things in.
Respect, the black hole certainly behaves like an object with the sun's mass. So we associate one solar mass with the black hole itself. In fact, if I give you a spherical object of any mass m, a spherical black hole with this special radius, called the Schwarzschild radius, will leave the space-time that's originally external to that object.
Yeah, so 2gmc squared rs, I don't know what that is exactly. Well, anyway, this Schwarzschild radius. But then he says this is about the circumference. And you're just saying, no, it has to be about the density of the mass. It doesn't really matter what the radius is. It matters of what the material you're making this black hole out of and how massive it is.
Unchanged. A black hole that mimics the sun has a Schwarzschild radius of 3 kilometers. One with the mass of Earth would have a radius of just under 1 centimeter.
Yeah, 1 centimeter, right? So these are rational numbers. You reduce the entire mass of the Earth to 2 centimeters, right? 1 centimeter with the radius, so 2 centimeters across. That seems practical or realistic to you, materially, that you could actually do that, take the entire mass of the universe, convert it into some sort of element, some sort of matter that has a atomic weight so massive that you could that you could realistically shrink the Earth down to 2 centimeters. I don't think so.
Hold on a second. A black hole is a bunch of events. So is that collection of events somehow
It's a collection of events. He just says it like, gee, we have an experiment that proves that. It's a collection of events. Fuck you. It's in the universe. It's made out of energy. Okay? It's not events. It's material energy. Energy is a material thing. It's not nothing. It's a something. Fuck.
mimicking mass, or does it actually have mass? Is there even a difference?
Oh yes, mimicking mass and having mass. Is there a difference? Well, I don't know. Show me something mimicking mass. This idea that you just say, okay, we can't explain black holes in any rational way, so we'll just say they're the only thing in the universe mimicking mass. How's that? I mean, why don't you fix all the problems you have, right? They have all kinds of problems with this math not working out, and they just won't admit. They just keep saying, it is the most proven, blah, 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 and then they have all kinds of problems where it doesn't work out the way they thought it would work out in terms of lensing and a lot of other things. So why don't you just make mimicking? Why don't you just say, okay? And they sort of have, right? That's what dark matter is. And dark energy.
Hold that thought, because first I want to debunk a few black hole misconceptions, and then we'll come back to this
Yeah, I think you're pretty debunkable there, buddy.
question. Misconception 1, that black holes suck stuff in. They don't do that. They're not that...
I don't really understand. They don't do that? They have... You're saying it's in the center of a galaxy's got a black hole or two inside of it, and it's tending to hold the galaxy together. You're using it as an explanation for the galaxy being held together, and now you're going to say it doesn't suck anything in. Well, that just doesn't make any goddamn sense.
vacuum cleaners. You can orbit them just fine.
Yeah, who said you couldn't orbit one at the safe distance? No one. So what are you debunking exactly? Who are you debunking with this bullshit that somehow black holes aren't just any other gravitational body in the universe? They're a gravity, a source of gravity. And all gravity is a shadow of energy. So it's blocking the energy that would be coming at me, right? From this little hole, there'd be energy coming at me. And it's blocking that energy, and therefore the energy behind me is going to push me into the damn thing. Vroom. That's how it works, buddy. I know you don't know that, but that's how it actually works. See, the stuff on this side gets blocked, can't move this way. So all the stuff moving this way can't get through there. You know, some of it does, but I'm just saying most of it does. You know, some percentage of it doesn't get through the black hole, and that determines how much gravity there is, because there's nothing getting on this side. So it's just like a visual shadow effect. Light behaves exactly like gravity. This inverse square principle works with optical objects just like gravity. So shadowing is a great way to look at it, because shadows, generally speaking, light moves in straight lines, and it's the straight lines that are making the gravity work. There's no going around the corner. Light doesn't do that.
I think this idea of suckage is rooted in a misunderstanding of the region that used to be inside the sun, but is still outside the black hole.
Well, again, that's your argument. Somehow you're the one converting suns into 3-mile thick objects, or Earths into 2-centimeter objects, and claiming that's what a black hole is. I say bullshit.
See,
I mean, clearly, if a black hole is 2 million sun masses, then it's going to be big. Yeah, even by your silly math. 2 million 3 miles is, 2 million times 3 miles is a pretty big object.
And geometry in this region is very foreign. For example, that is an allowed planetary orbit in that region. That region also...
I don't know whether this means anything. Does this mean anything to you exactly? That is an allowed planetary orbit. Just made that up, I would think. There has to be some reason why this would be skipping. So I don't even know why this, you're saying this is an allowed orbit. Allowed by what circumstance? What circumstance could possibly cause this to go this far and then jump over here and then jump over here? Where do you get the physics for that? Well, of course, we're going to get no explanation for that.
It has a cutoff radius inside of which there are no circular geodesics anymore. So, a free-falling observer inside that cutoff...
Well, again, inside that cutoff, inside. Inside is different than outside. So, yeah, you can't use the same physics to describe outside as you do for inside, because it changes as soon as you cross the event horizon.
Like the monkey, will go radially inward. But it's not because he's being sucked in, any more than the Earth sucks in a falling apple. He's just falling. As long as he stays up...
He's just falling. I mean, he's just falling? I don't even know what that means. We're all just falling. So what does that mean? It's still gravity, asshole. He's just falling?
Outside the horizon, he can use rockets to hover or move radially outward, just like on Earth. Misconception 2.
So was that a misconception? Did anybody think you couldn't orbit a black hole? No, nobody thought that. So I don't even understand what that was.
Black holes are black because not even light can escape their gravitational pull. That's not the reason. But here's my guess about how...
Yeah, that's not the reason, but here's my guess. That's pretty funny. Yeah, I don't, it's not the reason either, but that's what's predicted by Einstein's idea that gravity can somehow bend light, is that, yes, with enough gravity, you can stop light in its progression. That's the implication of bend. If you can bend light, you can break light, essentially, in terms of it won't be able to get anywhere because it'll just be caught in a circle, or it'll do things like every other gravitationally affected body if you have enough gravity. So that's the implications of that. And yes, and I would argue there's no, light is not affected by gravity. Gravitational lensing is a consequence of the junk, the charged bits, the electrons and ions produced by gravitational bodies like suns spew a ton of that crap. So yes, there would be lensing around suns because it's really dirty in the high atmosphere of suns. Even way out here where the Earth is, there's still particles flying off the sun that may not ever achieve escape velocity. They may end up going right back down to the sun again. It's very thick with energy.
This unfortunate metaphor started. In Newtonian gravity, a projectile on the surface of a planet or a star needs a minimum speed called the escape velocity in order to get really far and not turn back as it's pulled by the planet's gravity.
Well, let's just say slowed down to no velocity, and, you know, let's call it that. Where whatever velocity you give it on the surface, that velocity will be destroyed by the acceleration of the gravity. So you give it an acceleration, and that acceleration will be eaten up by gravity, and it won't be able to get past that line, and then it'll end up going right back down again once it stops, changes direction.
If a planet's radius equals the Schwarzschild radius of the equivalent mass black hole, it turns out that the escape velocity is the speed of light. But
right. So he's just saying the maximum, it just turns out. So this is, we're to believe it just turns out that it's the speed of light. But no, that's where the math has to terminate, because that's the constant. So it's just an arbitrary number that's based on the speed of light. It's not a coincidence or, you know, just happens to be. So let's play that again. This happens to be, just happens to be. No, it doesn't just happen.
But the escape velocity is the speed of light. But that's just a numerical coincidence. In general relativity, remember, gravity is not a force at all.
Okay, so in general relativity, gravity is not a force at all. So there you go. I mean, do you really believe that gravity is not a force at all? I mean, clearly it's a force. And clearly it's a force that's functioning in the same straight line dynamics that all these other forces are, like magnetism. And that's what it is. It's all the same thing. It's all one force. It's all a straight line quantized force. And the quanta is what light's made out of, and it's what gravity is made out of. And the only difference between gravity and light is that light has a frequency, and so we can detect it because it affects electrons in a certain way, where gravity doesn't affect them in the same way, so we don't see it. Gravity is affecting the little bits inside of the electron, where the electron itself is because of the frequency. It has a tuned frequency, so different electrons will be affected by different wavelengths of light, and we notice that. Different materials are affected differently by different wavelengths of radiation. And I guess I should call it radiation. It's quanta, it's gravitons. Light is like, if you could just call this stuff graviton, light's just gravitons coming at a specific period.
Even though it's true that everything inside a black hole, including a photon, will always move radially inward, it's not...
Well, see, look, the reason why it's moving radially inward is, again, this velocity argument. As it gains more and more velocity, and especially at this event horizon, the gravity is incredibly strong. The matter is converted into energy. So it's like a school of fish, and they're all moving in different directions, and as I move the school faster and faster, it means more and more of the fish are lining up with the direction of the velocity. And eventually all the fish will be going in the direction of the velocity. And when that happens, they're not really a school of fish anymore, it's just a mass of fish all going that way. You can really get this, can't you? You can get this. So yes, of course, everything goes in because everything is energy. It's all been converted by velocity, by the forced acceleration into energy. And energy moving in the direction of the velocity, which is the direction of the gravity. Duh.
Pull. Instead, the insane curvature.
Well, again, there's no pulling. It's all a pressure, so it's a pushing, but who cares? I mean, for right now, it doesn't matter. But these are like, and see, I'm going to play this video later, and I have to keep just writing these things down. But I mean, the key points are that gravity is a nuclear force. It affects the nuclear bits, the quanta inside the atom. Each little bit is being affected by gravity. Gravity is not affecting the mass, it's affecting the quanta. I mean, I don't mean it's affecting the mass in terms of affecting the body. It's affecting the little bits that the body is made out of.
Has made geometry so weird that radially out is simply not an available direction. Loosely speaking, it's like being in an episode of The Twilight Zone in which, no matter which way you turn, you're always facing inward. Now that's...
Yeah, well, whatever. Again, this isn't that hard to figure out, and if you understand, again, this is just a convergence. And that you can't cross the event horizon without having imposed on you by the fact that you're at the strongest gravity location, that anything, as soon as you move, you're going nearly the speed of light. You're going an incredibly fast acceleration, so therefore your school of fish can't be doing the swirling around thing because they have to all be moving the speed of light in that direction. And the only way they can move in that direction, the speed of light, is if they're all going in that direction, the speed of light.
Really freaky, but it's not the reason black holes are black. Remember, from our point of view, there are no photons inside. A laser pointer carried by the monkey never enters the black hole.
Well, look, the monkey no longer exists. The laser pointer doesn't exist. That's why there's nothing, okay? It's that there's nothing to produce the light, okay? So there's nothing inside the black hole. There's no mechanism, like an atom, to emit a photon. So there's no orbits inside here. The matter inside here can't be constructed in a form that allows it to eject bits, and that's why it's black. But again, then you'd have to explain how there's well, see, Hawking radiation would be the explanation. See, they'd say it's emitting Hawking's radiation, but Hawking's radiation is, again, just a form of light that's just invisible. That's what radiation basically is, the electromagnetic spectrum of radiation. So it's just a type of a cosmic ray, for example.
As far as we're concerned, because of time dilation, we would detect any laser pulse that the monkey sends with a lower frequency, i.e. a redder color, than whatever the monkey emits.
Right, but that's only because if the monkey has velocity. So as long as the monkey's moving nearly the speed, very fast, 3/4 the speed of light, very, very fast, and emits the light, then the light will be redshifted. But it's not redshifted by the region, it's redshifted by the movement of the monkey. If the monkey isn't moving, there's no redshift.
So just before the monkey freezes, from our perspective, the time dilation is so severe that any light he emits gets...
Well, again, the time dilation is just arguing that the atoms inside the monkey are moving very slowly, the orbits, and so the electron is producing photons that in normal circumstance they would be bit, really fast. And because the orbits are slow, it takes a while for photon 1 then photon 2 to come. So the emission of the photons, the gravitons that make up a photon would be 2 gravitons separated by a distance. The emission of that is altered because the metabolism of the atoms inside the monkey or the laser pointer are slowed down. So You can just understand my hand's moving slower, and if I emitted a graviton at the peak of my that movement, if I'm going this fast, then it's got a higher frequency, and if I'm going this fast, it's got a lower frequency.
Redshifted to undetectably low frequency. That means that to external observers, black holes are black because light that gets emitted just outside the horizon is redshifted into invisibility. So even though
Well, again, invisibility is a tricky word because we're talking about a redshift that would be back into like radio waves, and certainly they're visible. So to say it's invisible, I don't think would be fair to the argument. I don't think it's emitting anything. Yeah, so that's the real argument. The monkey isn't. The things going really fast aren't emitting anything. And if they are emitting anything, they're going to be emitting it in the direction of their acceleration. That's where they're breaking down. So that's the surface that's going to be